in this subject or in this course is the first review. So what are the term that we discussed or we learned last meeting? What are the terminologies na tumang discuss? Biotic and abiotic. So if we talk about biotic, masarap tayo natumabaw that is a biotic. Consumer, producer, o composer. That is the physical, di ba? That is a organism. Then, if you talk about abiotic, is an organic organism. That is like? Okay. It composed of non-living things. Okay? So this morning, we're going to discuss the population dynamics. Okay? So population dynamics, or that is the population of plants and animals, change over time. First is, may mag-change man ang population sa plants and animals due over time. So mag-change man siya. Because of, first, we have climate change. So mag-change ang population sa plants and animals through climate change. Second, the natural disaster. Because of the natural disaster, we have a natural disaster because of the climate change, di ba? We don't have a natural disaster if wala tayong climate change. Okay, first, climate change. Then, we have natural disaster. Third is the change in predator or prey abundance. Okay? So, mag-change in predator or prey abundance. So, may predator diri, ubalin dito, magka-change sa tuang population sa plants o sa animals because of the changes of predator or prey. Ubalin ang predator dili, daghan siya kan daghan ang iyang prey nga makahon. So that's why ma-change ang population sa plants and animals. Okay, that is the third. Is the change in predator. Next is the anthropogenesis. Okay. Because of the anthropogenesis, the population of plants and animals change over time. So these are the characteristics of populations. First is the size of the population. Second, the density of the population. Third is the dispersion. Then, the age distribution. That is the characteristic of, or the characteristics of population. Okay, so population measurements of population characteristics. First is the size. So size measure the number of individuals in the population at a given time. So methods, that is the quadrant and transect. So the first measure of population characteristic is the size of the population. Second, the population density, the second measurement of population characteristics. If we talk about population density, the number of individuals, the number of individuals of a population in a certain space at a given time. So the terrestrial ecologists express density as the number of individuals per unit area. Then, the aquatic ecologists express density as the number of individuals per unit volume. Yan naman. In the terrestrial ecologists express the density as the number of individuals per unit area. So the density of the population depends sa area. If it is the terrestrial density. Depende sa area na masulod. Di ba? Terrestrial is example, karamihan sa lawas. O depende sa area. Sa kasama. Okay, si Sirat. Okay. Si Sirat is kasama ko. Bisaya. Okay? So, if we talk about if this is terrestrial ecologies, it depends the per unit of area. Di ba? Chika ko sa mas pala siya buro, parasites? Parasite na siya buro? Parasite siya buro? Parasite. Kung tingog siya buro, tingog ng tanan. Okay, so if we talk about terrestrial ecologies, it depends the per unit of the individual, the number of individual per unit area. It depends the area of our ecosystem. Then, if we talk aquatic ecologies, express the density at the number of individual per volume. So, how the individuals sit in that area. That is the volume. Example is, this is another example. If we talk about aquatic ecologies expressed in the density. Aquarium, right? So aquarium, it depends the individual per unit volume inside the aquarium. Okay? Okay, that is the human population density. So the color red, that is the person per hectare. 10 to 50 person per hectare. Okay, that is the human population density. Third is the population dispersion. The population dispersion is the special pattern in which the number or the member of population are found in their habitat. So that is the population dispersion. So in the population dispersion, we have clump dispersal, that is the most common, uniform dispersal, that is the rare, and the random dispersal, that is the another rare. So if we talk about clump dispersal, that is resource are usually pathy in nature. Additionally, some animal species from grazing herd, schools of fish, flock of bird, and troops of primate to protect against predator. That is the clump dispersal. What is the example of clump dispersal? The example, a group of animal or species. They are put together, then, nag-group sila because of what is the use? Hinag-group sila to protect against the predator. Yes, amigas, right? Ants. That is the clump dispersal. So nag-grupo sila. They are formed as a group. So the animals or any kind of organism, okay, ingon, anak. So nag-form sila o group. So nag-usa sila. That is the clump dispersal. Then the uniform dispersal, that is occur mostly when individual of the same species compete for resources that are scarce or when a species define its territory by physical or chemical needs. Okay? That is for the uniform dispersal. The random, that is occur when the resource or condition is the environment are fairly uniform and competition is limited. If the competition of that habitat is limited, that is the random result. So, bulag-bulag. So, limited lang ang competition in that area. Okay? That is the example of clump elephant. They are formed a group so that, the predator cannot attack. So against the predator, they are formed as a group as against the predator. Okay? Clump. Uniform. It is uniform. Uniform. Kana the area is maura sila tanan, usa ra tanan. That is uniform. A group of group of sagbot. Bash. Okay, that is a uniform. The same ra sila tanan. So wala natin sa doon nila, the same ra. That is a uniform. A random is okay. Okay, that is the example of uniform and random. Hindi nga dito sa size. Sir? Okay. Next structure is the age. So, age structure is the proportion of individual in each age group in the population. We have pre-reproductive, reproductive, and post-reproductive. So, a population with a large percent of each individual in the pre-reproductive category has a high potential for growth. That is population momentum. So these are the human age structure diagram. For the Sweden, okay, these are the structure. For the Mexico and the United States. So, lino kung saan siya natuig na reproduction. Sabi mo nga picture. Okay? Next, what limit population growth? So, saan ang mga limit sa population growth? First, we have birth, death, immigration, and immigration. So, first we have birth, death. That is the limit of population growth. Because of birth, death, immigration, and immigration. So the population changes is equal to B, or that is the birth plus immigration minus death plus immigration. Okay? Di-plus tanang add sa tuang society. Minusan sa tanang nawala. That is birth and immigration minusan sa death or nawala, which is death and immigration nga E. Okay? That is the formula for the population change. So, tanang na puno for all population na na-add sa tuwang society, that is minusan sa population na nawala. Or immigration, yes. The foreign or any individual or animals na nisunod sa atong habitat. Enter the habitat. That is immigration. Immigration is nigawas. So, nigawas sa atong habitat para mangita ang aming kasi taglalin. Okay, so that is immigration and immigration. So, immigration na immigration na is the foreign, entering a foreign country. So, a person that enter in your country, that is immigration. Immigrant na example, if sa animals, ang iro, okay, susunod sa inyong habitat, sa inyong area. That dog is an example of immigrant. Immigrant na If you talk about immigration, na E is leaving the foreign country. So, they are living in that specific habitat. Pag-ausin si parasites. Okay, so that is the formula for the population change. The earth plus immigration na minus death plus immigration na E. Okay? Next, the biotic potential. So biotic potential is the population varying in their capacity for growth when environmental factors are optimal population growth. So biotic potential is equal to population growth. So the intrinsic rate of increase R in the rate at which population could grow if had unlimited resources. So if that is limited resources, then the population should grow. Why? Why that if we have unlimited resources, the population could grow? Because of the resources. If there's more resources in that specific habitat or ecosystem, then the population could grow. Because of birth and also because of immigration because of unlimited resources. That is the population growth. If that is the intrinsic rate of increase or the R. R is expressed as a number of individual, or that is the intrinsic rate of increase is expressed as a number of individual per existing individual per unit time. Example is a number of new preferred month per existing. The number preferred month per year. That is dn over dt times 1 over n is equal to the intrinsic rate of increase. Okay? Next, where dn in the formula is the rate of increase of the population and n is the population size. R is the intrinsic rate of increase. This is therefore the theoretical maximum rate of the increase of population per individual. So dn over dt is the rate increase of the population where the n is the population size. Okay? The population with high intrinsic rate of increase is equal to R strategic or the generalness. So first, mini small offspring. Second, netted or no parental care. Early productive age. Most offspring die before reaching productive age. Small adults. Adapt quickly to environment change. High population growth rate. Population size. Then generalist niche, then low ability to compete, then early successional species, rabbit, koala, pisan, dove. Okay, that is the early successional species. That is the population with high intrinsic rate of increase. So that is the possible that with high intrinsic rate of increase because of the mini small offspring. Little or no parental care. Because of no parental care, then we have the high intrinsic rate of the population. Because of that. Okay? Next, the environmental resistance. So environmental resistance limit the growth of a population when all of the limiting factor in the environment work synergistically. So this result is especially decision of species. The key strategies, okay, we have low reproductive rate, specialized niche, competition of resources. Okay, that is the environmental resistance or the population decrease because of the low reproductive rates, specialized niches. So we have the population decrease. Okay, that's the population size. The growth factor of biotic potential. Decrease factor, or that is the environmental resistance. In the abiotic, we have favorable light, favorable temperature, favorable chemical environment. Then for the abiotic, we too much or too little light, temperature too high or slow, unfavorable chemical environment, if that is the decrease factor. Okay, for the biotic, the increase factor or the growth factors for the biotic is high reproductive rate, generalized niching and food supply, suitable habitat, ability to compete for resources. That is for the growth factor. For the biotic or for the decreased factor of biotic is low reproductive rate, specialized niche and adequate food supply, and unsuitable or destroyed habitat. Okay? So those are the population size. Okay, these are the graph of the population size or N. So almost that is the time. So the population size over time is, di ba, nagkadaghan na ito ang population. From lower, then this area, that is the killing capacity or the constant. That is the constant area. So over time, that is the population size over time. So parang sa ubos, that is the exponential growth or the decrease factor, right? So this area is the decrease factor, then the environmental resistance. So if mo increase ang iyang factor sa population, unang iyang graph is mutaas. Then this line is the carrying capacity or the constant. That is the constant or the key. Okay, synergy. Synergy is together a biotic potential and environmental resistance. Determine the carrying capacity or K, which is the number of individuals of a given species that can be sustained indefinitely in the given area. That is the synergy. Okay, we have exponential growth. A population does not have resource limitation, grows exponentially. So exponential growth start out slow and then proceed faster and faster. So nagkagamay sa 90 year 70 okay, nagkagamay by year 2000 is nagkadaghan ang exponential growth. That is the billions of people. So the exponential growth is formed as the G shape or G form. Diba in mathematical, if you talk about exponential, the graph of exponential is formed as a G shape. So paano yung form? So that's why they tawag siya exponential growth or form. Next, that is the logistic growth curve. So the logistic growth curve is involved the exponential population growth when the population is small and a steady decrease in population growth with the time as the population approaches to the peak or the carrying population. So logistic curve here, sigmoidal curve or S curve. Sigmoidal. So duha ang iyang curve, sigmoidal. Ang form siya of S. That is the logistic growth. So that graph is an example of logistic growth curve or is curve. Okay? It is the population size of thousands. So decrease the population over year. So kada year that is to decrease or to increase ang population. Another graph, number of sheep. So over here, the carrying capacity, then 8. And then 1850 to 1875 yung ubos. Then pag 1875 yung taas, yung ubos, yung taas 1925, then nagtaas. Uli sa graph until 1925. Pero karon is, ang shift na to karon is, sama, pinagagamay na. Diba? The population, the number of sheep over the year is nagka-decrease. Okay, that is the result. The population crashes. The only way to avoid crash in population is if individual of that species immigrate out the habitat into a new one with more favorable condition. Okay? Hing mag-crash man ang nato ang population because of the species immigrate out of the habitat because of the condition, ang ilang food, ilang prey nga makaon, di ba? Because of that, the population crashes.
Ang lugar
The condition na crash ang population, kung iubos ang ato ang population because of the favorable condition. Nang balhin sila, nag-immigrate sila sa another habitat because of the condition, food, or prey na ilang consume. Okay? One, the existing key of the habitat has been exceeded. So the environment becomes degraded and the new key is lowered. So, lowered ang atuang key. Okay. So, ato ang carrying result is lowered food because of that process. Okay. How does population density affect population growth? Ano man? How? The population density affect the population growth. First is the density independent population control. So factors that will affect the size of population regardless of its density. So example of the population density affect the population growth. What are the first example?
Natural disaster.
Okay, natural disaster. Because of that? Okay. An example is the Hurricane Katrina 2005 Indonesian tsunami. Because of that is nag-affect sa tuwang population growth. Because of the density, population density, nag-affect sa tuwang population growth. Because of the natural disaster, then okay. Nawala ang nag-increase ang atuang population.
Sabi ng tsunami, tinuod ng tsunami dyan sa Japan as well. Kita na sa research. Tinuod dyan to.
2014 mo to?
Dagat pinangamatay ko sa tsunami dyan.
Tsunami to, gamay na ng tsunami.
Tsunami, basta gamay.
Chinini, ata. Chinini.
Okay.
Chinini.
This is the Hurricane Katrina 2005. Measurements after Hurricane Katrina. So, after the hurricane, wala siya ang nakitabo sa tuwang density or sa tuwang area. Next, the density-dependent population control. First is the independent. This is the dependent population control. So, when the limiting factors in the environment have significant effect on the size of the population as its density per unit, area increase. So this include first, the competition for resources. Second is parasitism. Agoy.
Nakalusok sila.
Hanap ko sila. Tingnan na po sa guro. Second is the disease. Because of the disease, it can be affect the population growth. So this means that the population with a high density per unit area generally have lower birth rate and higher death rate. So low is equal to slow growth rate due to the carrying result of the environment. So that is a dependent population control. Okay, this is the density dependent example in animals. So if there are large number of prey in the savanna biomes where competition is high for limited resources, then more zebra will become weak. Okay, so this is and die. So if daghang prey ang area, then daghang mamatay or magka-disease. Because daghang kuman nga predator. If daghang prey, daghang predator nga anak. So the most impact is equal to, what is the impact? Young, weak, and the elderly. That is the most impact. Tungod kay bata, sadali na siya makuha. Weak siya, okay, dali na siya makuha. Then, elder, because of the disease. Next, infectious disease. So fish feed on human become infected and the bites human transfer the disease.
Like karon sir, kay anak ko sa Korean.
Sa'yo naman tayo sa Cagayan doon.
Infectious disease.
Infectious disease.
Ito dito. Kami tayo lockdown sa gani. Nag-lockdown sa...
Down.
Sir, kamu ka sir.
Of infectious disease.
Sir, kaya ako sa after eviction sir. Lockdown.
Lockdown at election kay
Yeah.
kay
Kay cancer na virus.
Virus. Sino
May
virus?
one fan.
Kung saan na mangyari sa
May one fan.
Okay.
Okay. So because of the infectious disease, over 25 million people
Dead.
die or dead because of that disease. So through insect, pistis or mga insekto is nagdala o disease na sa files.
Ganda na.
Okay, that is the population form in nature. A is the stable. So if the population is stable, ang iyang graph is okay, stable lang yan. Pagka-decrease, increase, decrease. That is stable population curve. If that is irregular, so mutaas siya decrease, mutaas siya increase, mukalit ako siya ibaba ang population rate, that is irregular. That if the cyclic is paana ang iyang graph. The eruptive is saman. Okay, taas ti siya o stable din, musaka, eruptive. So mukalit lang o taas. That is eruptive. Okay, so what we can learn from nature? We have living system have 6 key features. First is the interdependence, diversity, resilience, adaptability, and unpredictability. And also the limits. That is what we learn from nature. Okay, time check is, saan ka tama?
Sir.
10, 10. So, sa klase niyo sunod? Ano tayo sunod? Okay, so before we're going to start our topic tomorrow, natawag na? We're going to continue discussing this topic, then proceed to next topic.